Um, if you drop, just press the join button and you should be able to jump right back in. I know the connection's a little bit iffy. So this is third day. We're starting logarithms and compound interest, and eventually we'll be getting to derivatives with it. For today, I'm going to focus mostly on the algebra part, so it's going to be kind of an easy day. We'll look at some properties of logarithms and some ways that we can use logarithms to help plan out your personal finances. So I'm going to start off just by talking about what a logarithm is. So a logarithm is an inverse of an exponential function. So what that means is we could flip that function about the line y equals x and we would get the exponential function. So here's our logarithm function in blue and our exponential function in black. If you want to look at it analytically, then I can say that the log base a of b is equal to c, as long as a raised to the c power equals b in exponential form. So this is my definition of a logarithm. So what we can use this for is to solve what power I would have to raise a number to in order to reach a set number. So for instance, over here, I've got 4 raised to some power equals 1028. So with a logarithm, I can rewrite this. This is a to the c power equals b, so I would have log base a of b equals c. Okay, so that's just following my definition. So if we rewrite this in logarithmic form, then we can solve directly. And then I can check this by hand if I want, because I know if I wanted to solve this by hand, what I could do is break this apart. So 1028, if I divide by 4, is 4 times 256, divided by 4 again. So 256 divided by 4 is 64. 64 is 4 times 4 times 4. So there's 3 more 4s in this 64. So that's 5 4s, so 4 to the 5th power. So then x is 5. Okay, so that looks simple enough to do without a calculator right now. But what this logarithm will allow us to do is, if this number had been 1029, where it doesn't factor evenly, then I can still use this process with logarithms in order to figure out what my power would be. Okay, I'm going to go into a lot more applications in a second, but any questions on what a logarithm is? Okay. So I'm going to start off just looking at some basic annual interest, and we'll build up to our compound interest formula. So I've got $100 in a mutual fund, and I'm getting 10% interest per year. I want to know what would happen after 3 years. So if I'm getting 10% interest, how much interest am I getting in the first year? Anyone? How much interest am I getting in the first year? Okay, I'm getting 10%. 10% of 100 is 10, so I have a final amount of 110. After my second year, I'm starting with 110 then. I'll be earning an interest of $11 then to get $121, right? Okay, so if I kept doing this, I would end up with this. You can see that because I'm gaining interest on my interest as well, the amount of interest that I'm earning each year is actually increasing. So this principle is how we expect your savings to start earning money for you, and eventually how you can retire, so that once you don't have an income, your savings can become your income. You'll be kind of relying on earning interest on the money that you've already saved up over time. This is also how banks make money. When you deposit money into a bank, they will then take that money and invest it. So they might invest that in other people by offering people a loan, invested in a business by offering people a loan, or invested in the stock market, hoping to make some interest on the money that you've put into their bank. Okay, so if I wanted to rewrite this in exponential form, I could say that what I'm really doing is I'm multiplying my amount by 1.1. So that 1 is 100% of my 100, plus the 0.1 is an extra 10%. So if I multiply whatever my amount is right now by 1.1, I'll end up with my final amount. So if I do that, then this would be 100 times 1.1 raised to the t power. Okay, so if I wanted to know how many years it would take the account to reach $1,000, then I can use logarithm. So I'm going to set my account equal to 1,000, divide by 100 to get 10, and then rewrite this as a logarithm. So this is A, C, and B. So log base A of B equals C. Then I can plug that into my calculator and get 24.15 years. Now, because I'm earning my interest discretely, so that means I'm only earning interest at the end of the year right now, I would have to go to the 25th year to have more than $1,000 in this account. But it would take me at least 24.15 years to reach it. Okay, questions on anything so far? Okay. So going a step further, so this is everything from the last slide. If instead of doing what we did last time, we want to gain interest every quarter of a year instead of at the end of the year, then I would break this apart. So at 1/4 of the year, I would earn 1/4 of my interest rate. So after the first quarter, I would end up with $102.05. For the second quarter, I would start with the $102 from last time, earn another 2.5% interest, so that's 1/4 of the 10% I'm earning all year. And you'll notice I'm earning a little bit more interest than I did last time. So that if I keep doing this, then at the end I end up with more money than what I would have had if I just earned my interest at the end of the year. So this is going to be immediately important for you guys once you open your first bank account. Most of the time your banks, when you first go to offer a bank account, at least in my experience, will offer annual interest, which means your interest is compounded annually at the end of the year. If you ask your bank, you can usually get them to compound quarterly, because if they don't give it to you, you can always walk out and go to another bank. But over time, if you're going to save a lot of money in your bank, then this could end up being a lot over time. Can you guys still hear me? Okay. Okay, can you hear me now? Yes, okay, there we go. So one more time really quickly. If you are gaining your interest every quarter year instead of at the end of the year, you end up with more interest in the end, because again, you're gaining interest on the interest. So for that second quarter, you're earning more than just the $2.50 that you were in the first quarter. Banks are going to use this so that when you go to open up your first bank account, they'll offer you interest at the end of the year, usually, so compounding at the end of the year annually. If you ask them, they will usually give it to you quarterly instead, which will end up earning you more money of interest later on if you have a lot of money in the bank. Conversely, if you take out a student loan when you go to college, your student loans will usually be compounded quarterly or even monthly, because that makes more interest for the bank. You guys can shop around with different banks and look for, even if they have the same interest rate, which one is compounded the least amount of times per year. And that can save you a lot of money over time when you're paying off your student loans. Okay, any questions on compound interest? Okay, so I've got our formula here. So this just says our account balance will be equal to our principal times 1 plus our interest rate divided by the number of times we're compounding, raised to the number of times we're compounding times the number of years. Okay, so here it's almost like we were compounding 4 more times than what we had originally for the first year, but at 1/4 of the interest rate, which is what this formula actually does. So I'm dividing my interest rate by 4 in this case, but then multiplying the number of times I compound by 4. Okay. So here's one more example. This is one of my accounts that I'm using for my retirement. So I have around $46,000 saved for retirement so far. This is, oops, and I am 30 at the moment. If I made an average of 8% interest compounded quarterly, then I can use logarithms to figure out when I would reach a goal. So in this case, when would I reach $1 million so I can stop working? Now this is if I don't put any more money into this account, how long would it take me to reach $1 million if I just leave it alone? Okay, now you can see, looking at this, we've had a really good year in the stock market, and right now, my lifetime interest, if you're going to look all the way back in this account to 1971, has gained an average of 13.5% every year. So I'm kind of underestimating, but I want to underestimate when I'm in retirement planning, so I want to make sure I have at least enough to survive. Okay, so if I plug this in, we can use logarithms to solve. I'm going to divide both sides by 46,000, and then convert this into a logarithm. So if I do, I've got log base 1.02 of 100 over 46 is 4t, divided by 4, and I'll have 38.87 years. So that means by the time I am 69, this account will be worth $1 million if it continues to gain at least 8% interest. The point of this is, you guys don't have to be looking for a job that pays the most amount of money possible. As long as you're saving smartly and investing smartly, you can do something you enjoy. Like for me, I enjoy teaching, even though I could be making 3 times as much as a statistician instead of teaching statistics or calculus. I'm able to do something that I enjoy knowing that I'm safe for retirement because I've started investing early enough that compound interest will work for me. And you guys can do the same thing. Any questions on this? Okay. So a couple last things. Logarithms and exponents, because they are the inverse of each other, can cancel each other out. So if I had log base 2 of x equals 4, I could raise both sides to a base of 2, and this 2 log 2 will cancel. So I'll end up with 2 to the 4th power, or 16. Okay, so I've got a number of properties of logarithms and change of base formula that you guys are kind of going to explore in the homework, which is pretty self-explanatory. So I'm going to end up stopping here and then going back to our weight and tension problems that we looked at for our homework 2 class periods ago. Specifically the last one. Okay, I'm going to start with the last one, and then if you guys want to leave, you'll be free to leave whenever you want as soon as we finish the last one. If you want to stay, I'll do the rest of these. So I believe we did A and B in the last session for anyone that wanted to stay. So I'm going to start at C. Determine the acceleration of the system if there is a force of friction of 40 newtons, if our mass on the table is 10 kilograms and the mass hanging is 20 kilograms. So once again, I'm going to set my force equals mass times acceleration formula up. This is my net force. This is everything that's acting on the object, and my net objects in this case. I've got two. My net masses, so I've got two objects, and my net acceleration. Okay, so I'm going to resolve for acceleration first. Blow this up. We've got our force of friction acting on the object on the table, which would... writing in white. Our force of friction, which would oppose our force of tension on the other side, which is being caused by gravity. So really, the only two forces that we need to be concerned about, because these tensions are the same, are my force of friction and my force of gravity. Okay, so I've got our two forces. Friction, which is acting, I called this negative for me, and this one positive. If you change your signs, then the math will be the same, but you'll have a different sign. So my force of friction was acting in the opposite direction of gravity. So this is 40 newtons, and our gravity of the mass that was 20 kilograms hanging off the table, divided by all of my masses, gives me 5.2. Okay, I was also asked to find the force of tension if we had that force of friction. So there's two ways that I could have done that. I can either look only at the mass that is hanging, so that would be my 20 kilogram mass, which has a force of tension and a force of friction. Force of gravity for the hanging mass. So my force of gravity would be 9.8 times 20. My force of tension would be acting in opposition to that. For my picture, that's acting in the opposite direction of my positive sign, so that would be negative for me, which is why I'm subtracting. Then I've got my hanging mass, which is 20, and my acceleration we just found for the force of friction is 5.2. So then I can subtract 20 times 9.8 from both sides, and then divide by -1, and I get 92 newtons. If you use the opposite mass, then I would have, again, two forces acting on the mass on the table, force of tension and force of friction, with 10 kilograms of mass instead. And if you plug all of that in, we end up with the same result. So once again, my tension is opposing friction, my mass is 10 kilograms, and I end up with a tension of 92 newtons. Any questions on part C or D from the homework? Okay. Alright, thank you all for coming. If you want to head out, you can. If you'd prefer to stay for the rest of this one, then you can stay. I will post the answers for all of this for the homework out to both WeChat and Skype. Yes. Okay, say one more time. Text is off for some of the slides. Okay, I'll see if I can post as a PDF after this. Okay, so for this first one, if I want to solve for the force of the brakes that we need in order to stop us from rolling, so that would be what force I would need in order to oppose this component of gravity that's acting parallel to the surface. So if I solve for that force, I can set up a sine function. Here's 15 degrees. because this is a right triangle and this is 75 degrees, this must be 15 degrees. So the sine of 15 should give me my force um, for the brakes, since that has to equal my component force of gravity, is 207.1 newtons. Okay, if I want to solve for the maximum incline I can support, if I know my weight is 800 newtons, then I can also set up a sine relationship. So this is the sine of my angle here. Should be equal to opposite over hypotenuse, which is 300 over 800, and then my arc sine should give me the angle. If I have a 1500 Newton force that's stopping my object from rolling down a 600 incline, then I can set up my sine relationship again. So this time I'm solving for my weight. So the sine of 60 equals 1500 over weight, and then solve for weight. Okay, and then we did the same thing with your own weight. So your answers are going to vary on this one based on what you said your weight is. Okay, and the last one. So we had two angles here, angle A and B. If I have two angles A and B, then I can set up a tangent relationship. So this is my 12 inches from the other side to get my angles. So I'm using my distances to get my angles. That gives me 38.7 and 25.6 degrees. Then I can set up a system of equations. I have forces of tension. Blow this up a bit. Forces of tension that are acting vertically for both of these. And forces of tension that are acting horizontally for both of these. So I'm going to call this one V1, and I'll call this one V2. And then we've also got forces of gravity for the weight that's pulling down. Okay, so all the forces that are pulling down should balance with all the forces that are pulling up because the object is not moving. So that means my force of gravity should be equal to both of my vertical components when I add them together. So that's V1 sine theta and V2 sine theta are the vertical components of my tension. Should be equal to the weight, which is 5,000 newtons was given. Okay, then I also have a component that was moving left and a component that was moving right for V1 and V2 respectively. Those should cancel out because our object is not moving left or right. Our object is stationary. So that gives us a system of equations. I've got two unknowns, so I'm going to use my top equation and solve for V1. Once I've got V1, then I can substitute my V1 back into our V1 for the other equation. So anytime I saw a V1 here, I'm going to replace it with V2 cosine B. And then that allows me to factor out my V2. Now I only have one variable because we know it would be an AR. So I can divide by everything that's not V2 and get an answer. Once you've got an answer for V2, I can plug it into this equation for V1 and get an answer for V1.
Sir,
Go for it.
can I see the answer for number 3 and 4?
Yep.
Mr. Brendan,
Yes.
right. So like, if I have questions about the homework, like, for the one that's due tomorrow, is it the one that is like the challenging questions?
Yes, that's the projectile motion challenge questions.
Like the one, I have a question with the one about like Jenny kicking the